Welcome. In this video, we are going to watch the third unit of IGCSE CAE, that is atoms, elements and compounds. First, we should know that matters are made up of tiny particles. So matter in the sense, there are three states of matters. They are solid, liquid, and the third one is gas. So these three states of matters are made up of tiny particles. For example, sodium is made up of sodium particles, and those particles can be called as sodium atoms. As well as carbon is made up of carbon particles. So those particles can be called as carbon atoms. But when we compare these two particles, which means when we compare sodium as well as carbon particles, they are entirely different from each other. Okay, let's see the definition for atoms. Atoms are the smallest particles of matter. They are the smallest particles of matter. And also, atoms cannot break down further by chemical means. We cannot break down further. So this is the definition for atom. Atom has two parts. First one is nucleus and the next one is cloud. Inside the nucleus, protons and neutrons will be presented. So electrons will be presented in the electron cloud. Due to protons and neutrons are presented inside the nucleus, they are called as nucleons. And these three particles are called as subatomic particles. Okay, now we are going to see the atomic structure. So this is how an atom will be. So the core is called as nucleus, in which protons and neutrons will be presented. The cloud will be around the nucleus. So as we know already, in nucleus, protons and neutrons will be presented, and in the electron will be presented in the electron cloud. Next, we are going to see about elements. Elements in the sense they contain only one kind of atom. Let's see with an example. Sodium metal is made up of sodium atoms only, in which we cannot find any other kind of atoms. For example, you cannot find any carbon atom or you cannot find hydrogen atom in sodium metal. So sodium metal is made up of sodium atoms. So elements contain only one kind of atom. Around 90 elements are found in nature. Nearly 30 elements are created in the labs artificially. They are man-made elements. So man-made in the sense artificial. These artificial elements are mostly unstable. Many of these elements are stable only for 10 seconds, 1 minute. So due to this reason, these elements cannot be found in nature. So many of those elements are unstable in nature. Next, we are going to see about periodic tables. So in periodic table, element symbols, elements name, proton number, nucleon number, everything will be given. So for example, In carbon, C is the symbol of the element and carbon is the name of that element. Six is the proton number and 12 is the nucleon number. So these details we can get from periodic table. So in periodic tables, vertical as well as horizontal lines are there. Horizontal. Vertical in the sense top to down. So these lines are called as groups. There are 18 vertical lines in periodic table, which means there are 18 groups. Horizontal in the sense left to right or right to left. They are called as periods. There are 7 horizontal lines in periodic table, which means there are 7 periods. Next we are going to see more about atoms. We know that all particles are made up of atoms and atoms are very light which cannot be weighed easily. So the mass of atom is calculated by atomic mass unit. So atomic mass unit can be calculated by the particles which are presented in the atom, which means subatomic particles. Let's see the mass and charge of those subatomic particles. First we are going to see about proton. So the mass of proton is 1 unit and the charge of proton is positive, which means +1. Next, neutron. For neutron also mass is 1 unit and the charge of neutron is none, which means it is neutral. Next subatomic particle is electron and the mass of electron is almost nothing. The charge of electron is negative, which means -1. Next we are going to see how the subatomic particles are arranged in an atom. As we know already, proton and neutron are presented inside the nucleus, whereas electrons are presented in the cloud. Let's see the atomic structure. So this is how an atom will be. The protons and neutrons cluster together in the center, forming the nucleus, and nucleus is the heavy part of the atom. So as we know already, proton has 1 mass unit, neutron has 1 mass unit, whereas electron has 0 mass, almost 0. So due to that, nucleus is the heavy part of the atom and electrons circle very fast around the nucleus at different energy levels, and these energy levels are called as shells. Next we are going to see what is proton number and how it can be calculated. So number of protons in an atom is called as proton number and it is the identity of an atom. For example, carbon. Carbon has 6 protons. For example, sodium. Sodium has 11 protons, which means if an atom has 6 protons, it is called as carbon. As well as if an atom has 11 protons, it is called as sodium. So proton number is the identity of each and every atom. So identity of an atom is proton number. Next we are going to see what is nucleon number and how it can be calculated. So total number of protons and neutrons in an atom is called as nucleon number. So as we know already, protons and neutrons are presented inside the nucleus, due to that they are called as nucleons. So the total number of protons and neutrons is called as nucleon number. For example, sodium has 11 protons and 12 neutrons. So the nucleon number of sodium is 23. And for carbon, so in carbon there are 6 protons and 6 neutrons. So the nucleon number of carbon is 12. So this is how nucleon number should be calculated. Next, we are going to see how many electrons can be presented in an atom. So every atom has same number of protons and electrons. Then only the atom will be neutral. Let's say with an example. In sodium atom, there are 11 protons and 11 electrons. So the charge of proton is +1 and the charge of electron is -1. So we will get 11 plus and 11 minus. So the net charge will be 0, which means sodium atom will be in neutral charge. If sodium has 11 protons and 10 electrons only, then we will get 11 plus and 10 minus. The remaining will be 1 plus, which means the atom will not be in neutral charge. So to be in neutral, an atom should be having same number of protons and electrons. Then only the atom will be in neutral. Next, we are going to see isotopes and radioactivity. As we know already, each atom is identified based on the proton number. For example, if an atom has 6 protons, it is called as carbon. Like that, each and every atom is identified by proton numbers. Isotopes in the sense atoms of same element with different number of neutrons. Most elements have isotopes in nature, which means most of the elements have same number of protons and different number of neutrons in nature itself. For example, carbon has 3 isotopes. They are carbon 12, carbon 13 and carbon 14. As we know already, proton number is the identity of each and every element, and here you can see that in these 3 carbon isotopes the proton number is 6, whereas the nuclear number is different from each other. Let's see elaborately about the number of protons and neutrons in these 3 carbon isotopes. First, in carbon 12 isotope. So in carbon 12 isotope, there are 6 protons and 6 neutrons. Due to that, the nuclear number is 12. Next, in carbon 13 isotope. In carbon 13 isotope, there are 6 protons and there are 7 neutrons. Due to that, the nuclear number is 13. Next, in carbon 14 isotope, the number of protons is 6 and the number of neutrons is 8. Due to that, the nuclear number is 14. So isotopes have same number of protons but different number of neutrons. That's why we are calling it as atoms of same element with different number of neutrons. So this isotope can be called as carbon 12, and this isotope can be called as carbon 13, and this isotope can be called as carbon 14. Next, we are going to see about radioactivity. Some isotopes' nucleus are unstable due to the imbalance of protons and neutrons. So that kind of atom breaks down into smaller pieces naturally without any external force. Either it breaks down into smaller pieces or it decays. So the unstable isotope's nucleus will be decayed by emitting radiation. So this radiation will be in 3 forms. They are rays, particles, and energy. Let's see elaborately about these 3 forms of radiation. First one, alpha radiation. Second one, beta radiation. Third one, gamma radiation. And the last one, neutrons. So alpha rays in the sense, if during the decay, if 2 protons and 2 electrons are emitted, they are called as alpha rays. If high energy electrons are emitted, during the radiation, they are called as beta radiation or beta rays. Next, regarding gamma rays. If high energy rays are emitted, and they are called as gamma rays. At last, neutrons, we know what are neutrons. So these are the 4 different types of radiation which are emitted during the decay of unstable isotopes. These unstable isotopes are called as radioactive isotopes. Either they can be called as radioactive isotopes or radioisotopes. Let's see with an example. So as we know already, carbon has 3 isotopes. Out of these 3 isotopes, carbon-12 and carbon-13 are non-radioactive, whereas carbon-14 is radioactive, which means the nucleus of carbon-14 is unstable and it will decay into smaller particles by emitting radiation. Due to that, it is called as radioactive isotope. Next, we are going to see about half-life. Half-life is nothing but it is the time taken by an isotope to decay half. Let's see with an example. If you have 100 grams of radioactive isotope, it will be decaying by emitting radiation. So after some time, it will become of 50 grams. So this will occur by the decay of unstable isotope. So it will take some amount of time to become half. So this time is called as half-life of that particular isotope. Next example, the half-life of carbon-14 atom is 5730 years. As we know already, carbon has 3 isotopes, and out of those 3, carbon-14 alone radioactive isotope, and it has the half-life of 5730 years. For example, if there are 100 atoms of carbon-14 on the first day, after 5730 years, the number of carbon-14 atoms will become of 50 because of the decay or because of the radiation. So this is what half-life. Half-life is nothing but it is the time taken by an isotope to decay half. Next, we are going to see half-life of some of the radioactive isotopes. So radon-220 is the radioactive isotope and it has the half-life of 55.5 seconds. So after 55.5 seconds, the number of atoms will become off. As well as for cobalt-60, it is 5.26 years. For potassium-40, it is 1300 million years. So these are the half-life of these 3 isotopes. As we heard about radioactivity, it is very dangerous because it will kill the human cells. When it passes through our body, it can kill the living things. Overdosage of radiation will lead to radiation sickness. Overdosage of radiation will lead to radiation sickness. Sometimes overdosage will lead to cancer. Overdosage will lead to cancer sometimes. So we should not be in radiation for long time. Next, we are going to see the uses of radioactive isotopes. First use, to check leaks. In some oil and gas factories, they will use radioactive isotopes to find out leaks in gas and oil pipes. There is an instrument called Geiger counter. Geiger counter. So which is used to find out the radioactivity. It is used to find out radioactivity. So what they will do is they will send the radioactive isotopes inside the pipelines. They will check the radioactivity outside of the pipelines. If Geiger counter shows the result, then what it means? There is a leak in gas or oil lines. So this is how they will use radioactive isotopes to find out leaks in the pipelines. These radioactive isotopes are called as tracers. Next use to treat cancer. We have seen previously that radioactive isotopes cause cancer, as well as we have seen that radioactive isotopes can kill living things. So here the treatment is called as radiotherapy, in which radioactive isotopes will be passing through our body and it will kill the cancer cells. So to kill the cancer cells, we are using radioactive isotopes, and the treatment is called radiotherapy. Usually we are using gamma radiation for radiotherapy. As we have seen already, gamma radiation is nothing but high energy radiation or high energy rays. So for this radiotherapy process, the radioactive isotope which we are using is cobalt-60. So this is the isotope which we are using for radiotherapy to kill cancer cells. Next use that we are going to see is to kill germs and bacteria. Here also we are using gamma rays, which means the high energy rays, to kill bacteria and germs. Usually we are using this gamma rays to sterilize syringes. And also in some countries they are using gamma rays to kill germs and bacteria from foods. Foods in the sense they are using gamma rays to kill germs and bacteria from vegetables and fruits. Initially, gamma rays will be passing through food items. So after the passing, bacteria and germs will be killed. So here also we are using cobalt-60 as the radioactive isotope. Along with cobalt-60, we are using one more radioactive isotope to kill germs and bacteria, that is cesium-137. So these are the two radioactive isotopes which we are using to kill bacteria and germs. The last use of radioactive isotope is carbon dating. In our body, we are containing some amount of carbon-14 isotope. As we have seen already, the half-life of carbon-14 isotope is 5730 years, which means even after our death, carbon-14 isotopes will be there in our body. So by measuring the radioactivity of carbon-14 isotopes, we can calculate the ages of fossils. So by measuring radioactivity of carbon-14 isotope, we can find out the ages of fossils. Because of carbon-14 only, archaeologists are finding out the ages of mummies. So these are the 4 uses of radioactive isotopes. Thank you for watching. We'll see you in the next video. Thank you.